All right, hello everyone. Today we are taking on midpoint and distance formulas. So first up, we're seeing this language bisect. So to bisect something, it means to divide something into two congruent parts. When we see that prefix bi, we know that that means two. So two parts that are exactly the same. Okay, so again, to bisect means to divide a segment into two congruent parts. So the way that we show that, we have a segment, it has these two endpoints. So I'm going to draw a point that is right smack in the middle, right about here. That would be the midpoint. I'm going to define that in just a moment. And then each of these two segments would be congruent. They would be identical. We can show that with tick marks. Okay, next up, we're looking at midpoint. So the midpoint is that specific location that divides a segment into two congruent parts, where both of those portions, they match perfectly. So here I'm going to define it first. So it is a point that divides a segment into two congruent parts. Okay, so right here, right about right there, that would be my midpoint, right? It's a location, the middle point, and it takes this larger segment and divides it into two congruent parts. So I can show that with, again, a tick mark here and a tick mark here. It shows that these two parts, they match perfectly. Okay, next up, we have segment bisector. So a segment bisector, it could be a line, it could be a ray, it could be a segment. Let me start with that. So a line, a ray, or a segment that divides a segment into two congruent parts. Okay, so we're looking at a line, array, or a segment, so some sort of straight pathway that divides a segment into two congruent parts. So let's say that I draw it as a line, but again, it could be a ray, it could be a segment, could be another figure. I could just draw in a line, say a line just like that, that slices through this segment, and when it does so, it divides it into two congruent parts just like so. So we know that it could be a midpoint, right, that splits a segment into two congruent parts, but it could also be a line, array, or a segment bisector, right? Anything that divides a segment into two congruent parts. Okay, next we're looking at a more specific type of segment bisector. We're looking at a perpendicular bisector. So a perpendicular bisector is a type of segment bisector that cuts through at 90 degrees specifically. So let's start with that. So it is a type of segment bisector that cuts through or intersects at 90 degrees. So perpendicular, sometimes we use this notation of a little upside down T like that. That represents perpendicular. And again, it's a type of segment bisector. So I'm going to draw in, I'll use a line for my example like this. So I'm making my line, my segment bisector, and it cuts through at 90 degrees. So I can show that with a little box notation here. So I know that all of these angles then must be 90 degrees. So I'm creating this perpendicular pathway, splits through my segment, and it divides it into two congruent parts. Okay, So now also one other thing to point out, let me just take a pencil for a moment. If I trace my pencil along the perpendicular bisector, let's say that I stop right here, for example. If I was to connect this point to the end point of this initial segment here, and I connected to here as well, it would be perfectly congruent. The distance here will match the distance here. And that will be true anywhere I drag my pencil along this perpendicular bisector. So if I stopped right here, for example, and connected to this endpoint and to this endpoint, it would be the same thing. So any point along the perpendicular bisector is going to be equidistant, same distance, to the endpoints of the initial segment. So let me add that over here. So any point along the perpendicular bisector is equidistant, so same distance, to the endpoints plural, of the segment. And let me draw you a little mini example off to the side. So let's say that here is my initial segment. Let's say that I call it AC. I'm going to draw in a perpendicular bisector like so. I'm drawing it as a line. Here's that right angle. And here's the tick mark to show that the segment itself got bisected. So then if I take a different color, let's say I put a point right here, and I call that point B. If I connect B to A, and I connect B to C, those distances will match. These pathways will be perfectly, they'll be identical. The segments themselves here will be congruent, right? The measures would be equal. So I can say that segment AB will be congruent to segment CB. I can also say that their measures will be equivalent. So the segments are congruent, they're identical, same size, same shape. If I pick one up, it's going to overlay with the other one perfectly, and therefore their measures must be the same as well. All right, next up we're looking at midpoint formula, and we're looking at distance formula. So here what I'm going to do is I'm going to look at my model. I have points C and I have points C and D. So let me first just draw in my midpoint right here and label it. So my midpoint right smack in the middle of those two endpoints, right, it will make here and here congruent segments. So I'm going to add those little tick marks right there. And then when I'm trying to picture what would be the midpoint's x value, well, what I'm doing is I'm picturing the two x values that are marked here and here. So whatever they are, let's say that this had a value of 2 and this had a value of, say, 12. Well, I know that it would have to be somewhere in the middle, right? Because if I trace this down here, the x value, trace this down here, I know it has to be right smack in the middle. So I'm really looking at the average of those x values. Okay, and then when I'm thinking of the y values, here's my y1, here's my y2. I'm really doing the same thing. I'm tracing it over and tracing it over like that. And I'm trying to find the average of those y values, right? That will find the y value right here for that point. So when I think about it, it makes sense. My midpoint is simply the average of the x values. So I would add the two x values and divide by 2. I'm finding the average of two things, so average of the x values. And then I need the average of the y's. So I add the two y values and divide by 2. So that would be my midpoint formula. But again, I like to think of it in words, right? I'm looking at it as the average of the x values, and then the average of the y values. Okay, let me box my formula. So I add the two x values, I divide by 2. I add the two y values, I divide by 2. That's how we average. Average of x, average of y. Okay, the distance formula, before I even get started, what I want to do is I want to remind you of the Pythagorean theorem. Let me write that off to the side. So Pythagorean theorem. So we know that Pythagorean theorem pertains to a right triangle where the two legs are A and B, and the hypotenuse, the longest side opposite the right angle, that is C. So Pythagorean theorem is a squared plus b squared equals c squared. And all I'm going to do is I'm going to switch sides. I'm going to rewrite this as c squared equals a squared plus b squared. So let's say that I was solving for that unknown hypotenuse. I'm solving for c. That's why I put the c squared on the left-hand side. So to solve for c, I'm going to unlock the square by taking the square root. And in doing so, that's telling me that c, my hypotenuse, is equivalent to the square root of a squared plus b squared. So I know that my hypotenuse is equal to the square root of the sum of a squared plus b squared. So I'm just reminding you of that before I get into the distance formula. Okay, so what I'm going to do with the distance formula is I'm looking at my segment. I want the length of this segment. I want the distance from E to F or F to E. So distance and length, we often use that language interchangeably. So the distance from one point to another is the length of the segment. So I'm going to call it D for distance. Okay, so here I'm also thinking of, if I'm trying to find this measure, I want to find the horizontal distance that they are apart. So this would be the horizontal distance they would be apart. And I also want the vertical distance that they are apart right here. And in doing so, I'm making a right triangle similar to the one over here, where my distance, the D, is now the hypotenuse of a right triangle. So when I'm picturing here, what's that horizontal distance they are apart? Well, I'm looking at the x values again. And I want to take the difference between them. So since this one here is further away from the y-axis here, I'm going to do x2 first minus x1. So imagine that this point was, say, 10, the x-coordinate was 10, and this was 2. So I'm 10 units from the y-axis. I'm 2 units from the y-axis. They are 8 units apart. So I'm just giving you that as an example. Okay, for my y values, the vertical distance they are apart. So here I'm taking this y value. Let's imagine maybe it's 6 units. Okay, this y value here, let's imagine that it was 4. So I'm 6 units from the x-axis. I'm 4 units from the x-axis. So the difference between them, it would be 2 units apart. So here I'm just going to label this as y2 minus y1. So difference between the y values. So now if I'm looking at Pythagorean theorem, remember what I had here. I'm going to remind you of this. C squared equals a squared plus b squared. Well, in my example, D is the C. So my distance squared is equal to. Okay, if I look at this leg, it's the difference between the x values. So x2 minus x1 squared. And then up here, difference between the y values, that's my other leg. So y2 minus y1 squared. So again, I'm really just following Pythagorean theorem. I just have more variables in the mix now. So now to get to the d, to get to the distance all by itself, to unlock that square, I can take the square root of each side. So my d, my distance, the length between the two, is equal to the square root of here, difference between the x values squared, plus difference between the y values squared. Okay, and that's our formula. And the order that I actually take the x values and the y values, it wouldn't matter because squaring it will force those quantities to be positive anyways. So if I had written x1 minus x2 or y1 minus y2, that would have been fine also. All right, next up, here we're just going to use those two formulas. So the endpoints of GH are given. Find the midpoint and the length. Okay, so let's do midpoint first. So here we're looking at average of the x's, average of the y's. So I have -3 plus -9 over 2. To find an average, we add them together, divide by 2. And now I need the average of the y's. So 5 plus -1 divided by 2. So now -3 plus -9 is -12 divided by 2. 5 plus -1 is 4 divided by 2. So now when I clean this up, I get -6, 2. That would be the location of the midpoint. And if I go back and I look at -3 and -9, is -6 right smack in the middle of those two numbers? Absolutely. How about the 2? Is the 2 right smack in between 5 and -1? Absolutely. There's always ways to double check. Okay, and then I want the length. Length is the same as distance. So I have my big square root, and I want the difference between the x values. The order does not matter. So I'll say -3 minus -9 and then squared. Okay, plus difference between the y values. 5 minus -1 and then squared. Okay, so this is where I'm at right now. Big square root. Here, difference between the x values, the order doesn't matter, squared, plus difference between the y values, order doesn't matter, squared. Okay, when I subtract a negative, it goes to a positive. So I have a positive here and a positive here. So my next stage, I have 6 squared. And here I also have 6 squared. So I have 36 plus 36 underneath my square root, which then becomes 72. So I have the square root of 72 right now. We always want to leave our answers simplified. Simplify those radicals. So I know that 72 is 2 times 36. 36 is going to give me a pair of 6's. So my final answer would be 6 times the square root of 2. That would be my length. That would be the distance. And then again, we always want to make sure that we simplify radicals. Okay, if I did this without a formula, you're going to see me do this a lot. Let's say that I just wanted to visualize it. I could always make a right triangle off to the side. And then what I'm picturing here, how far apart are the x values? Well, they're 6 units apart. How far apart are the y values? Oh, they're also 6 units apart. This is what I'm visualizing in my head. Okay, so I know that my distance will be the square root of 6 squared plus 6 squared. And it's taking me back to this point in my formula right here. So if you like a formula, this is how you're going to do it. If you'd like to visualize it with just using the right triangle, this is fine too. Either way, we're going to end up with 6 root 2 as our final answer. All right, a few more problems on that second sheet. So please pull out that second sheet now. Okay, here is example 2. So the midpoint of a segment, we're given the point, the midpoint is 2, -3. One endpoint P is 4, 1. Find the coordinates of endpoint Q. Okay, there's a couple ways we could do it. I can do this in this intuitive way, or I could do it with a formula. I'm going to show you both ways. So let's say that I draw myself just a picture of what's going on. Here is P, here is Q. M is the midpoint right here. We're told its location is 2, -3. We're told that one endpoint is P, and that's at 4, 1. So I'm not trying to draw this to scale. I'm just giving myself this little visual anchor. Okay, so now again, it's a midpoint, so I know that these segments are congruent here and here. I'm trying to figure out Q. So what I'm doing is I'm going to look at the X values first. So here, my midpoint is 2, and I can see that to get to 4 here, right, there's that X value, we had to add 2. So to get to what Q's X coordinate is, I must have to take away 2. Because when I'm averaging, if two numbers are, I'm trying to average two numbers, the average is right smack in the middle. So let's say, for example, I have 10 and I have 20. If I say average those two numbers, well, then it would be 15. 15 would be right smack in the middle. There, so you can see it. So 15, I would take away 5 to get to 10, and I would add 5 to get to 20. So again, that's how an average works. So that's what I'm doing right here. If 2 is the average of two numbers, then I had to add 2 to get to 4. I must have to take 2 away to get to 0. So I know what the X coordinate is, but I don't know the Y coordinate just yet. Okay, if I focus on the Y's, underline in green, I can see that to get from -3 to 1, we had to add 4. Which means that if I'm going after the other Y value, I must be taking away 4. So here, to get to that Y value, -3 minus 4 is -7. So that actually gives me the coordinate of Q right now. It's at 0, -7. And that's using just this kind of intuitive approach because we understand how an average works. Okay, if you don't like that, let me show you a more algebraic approach. So let's say that I want to find X. I know what my midpoint's X value is. I know it's 2. So I know that this endpoint, where the X value is 4, plus my unknown X value, when I divide it by 2, has to get me to the midpoint coordinate of 2. Okay, and let's say that I want to get to X. Let me build an equation here too, and then I'll work through the mechanics. So for the Y, the missing Y value, again, I know that my Y of my midpoint is -3. I'm given one endpoint where the Y value is 1. So I know that 1 plus that unknown Y value divided by 2, the average of those two Y values, will get us to -3. So again, this is just a more algebraic approach using the idea of an average. So now I just have to solve for X and solve for Y. So I would multiply by 2 to clear the fraction. So 4 plus X equals 4. Take the 4 away from each side. X equals 0. Great, I have my X coordinate. It's exactly what I said it was earlier. Okay, over here for the Y, multiply each side by 2. 1 plus Y equals -6. Take away the 1. Y is -7. Again, it's just confirming what I already said. That is the location of that missing endpoint, point Q. So a midpoint is an average of the X values. It's an average of the Y values. So I can use my more intuitive approach or a more algebraic approach. It doesn't matter to me. All right, next up. So here we're doing a little polygon review, little vocab. So a polygon is a closed spatial figure or plane figure with many sides. Let's start with that. So a closed plane figure with many sides. Okay, when we name a polygon, we name it by listing the vertices, all of the points, in a consecutive order. So let me give you an example. And you'll see that I love to make words. So I'm going to make a hexagon. Hexagon is a six-sided figure. So 1, 2, 3, 4, 5, and 6. Okay, I'm going to start right here, and I'm going to label F, L, A, S, H, Y, like that. So there is my hexagon. I've labeled all of the 6 vertices, all of those points. So let's say that I start here and I'm going in consecutive order. I could go in this clockwise order and read it as F, L, A, S, H, Y, right? Flashy. But I could also start with the F and I could go against the clock. I could go counterclockwise like this and name it F, Y, H, S, A, L, like that. So starting from point F, I have 2 directions I could go in for naming my polygon, specifically my hexagon here. So I could do the same thing from Y. I could go left or right. I could go clockwise or counterclockwise. Same with H and so forth. So really, there are 12 total ways that I can name this 6-sided figure, this hexagon. So if I was making a figure that had, say, 8 sides, an octagon, I would have double the ways of naming it. So if I have an 8-sided figure, I have 16 ways to name it because from each vertex, each point, I could go clockwise or counterclockwise. All right, we have convex and we have concave polygons. So if we have a convex polygon, that means that we have no angles that are pointing inward. Okay, I can also think of that as there's no interior angles that are more than 180 degrees. Okay, so let me give you a couple examples. So I could draw a triangle, for example, like that. That would be a convex polygon. I could draw a quadrilateral, so something with 4 sides like that. That would be a convex polygon. I could draw a 5-sided figure. I could draw a pentagon that looks like this, also convex. So no angles pointing inwards, no interior angles more than 180. 180 is just a straight pathway, so we don't see any angles that are in excess of 180. So concave means that we do have an interior angle that's greater than 180. So has an interior angle greater than 180. And again, 180 is a straight pathway like that. Okay, and then if I just make it even simpler, you can think of it as it literally has a cave in it. So has a cave in it. So let me give you a couple examples here. So let's say that I draw a pentagon, 1, 2, 3, 4, 5 sides. So that's still a pentagon. It has 5 sides. It's just concave. It's concave because it has a cave in it. This angle right here, would be in excess of 180. Let me draw another one. So let's say I start with kind of the same structure here, but maybe I go up, maybe dip in, up, and over like that. So I've just drawn a 7-sided figure that is concave also. It has a cave in it. It has this interior angle right here that is in excess of 180. So again, I'm focusing on that angle right here. All right, so convex, no angles pointing inwards, no interior angles more than 180, and concave literally has a cave built into it. It does have that interior angle greater than 180. Okay, lastly, just going over some language, classifying polygons by the number of sides. So 3 sides is our triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides is an 11gon. And 12 sides is a dodecagon, 2 more than 10. Dodecagon. Okay, let's do it together one time. Okay, just repeat after me. Let's do it together. So 3 sides is a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides is an 11gon. And 12 sides is a dodecagon. So these are the ones that you guys need to know. You need to know sides 3 through 12. Anything that is beyond that, anything with say like 23 sides, I will just say a polygon with 23 sides. Everything else, if it's 3 through 12, you need to know the vocabulary. Okay, anything beyond that, you do not. I will specify the number of sides. All right, that's all I have for today. Have a good rest of your day.